Hi, my name is Rafael Fernandez Cardenas, and I'm here to present my project, which is based on Pendulum. Okay, well, let's first start with the questions and the hypothesis. In order to start, I made a general question in order to get the idea of what I wanted to do. And this general question is, how does the frequency of a pendulum vary with string length? But after that, I needed to get more specific in order to see what results I needed and how I was going to measure them. So my specific question is, how does the time it takes for the ball attached to a string, the pendulum, to reach stop after being dropped horizontal to the origin point is affected through the string length? Hypothesis. My hypothesis is basically the longer the length of the string, the longer the time it takes for the ball to reach stop. So now we move on to identifying the variables. The independent variable, which is the one that it's not dependent of the experiment, which means the one that we can control. Well, the one that we can manipulate is the length of the string at which the pendulum is swung. The dependent, the one that is dependent on how the independent is manipulated, is the time it takes for the ball to stop. And the control variables, which are the ones that do not affect and do not change throughout the experiment, is gravity and the material of the ball and the string, as well as the origin and dropping point. Now, we move on to methods to avoid changing the control variables. In order to basically be on track with the control variables not changing, we need to do some things. And what I realized is that we can, the ball and the string of the material, okay, the ball material and the string material will be the same at all times. Also, the measurement will be divided in sections on the same string. There will not be different strings that will make up the experiment. Also, the origin point will be grabbed in the mark, and the string will be taught horizontally on the left side and then dropped. Well, gravity does not change unless we are on another planet, so that's good. Now we move on to how the variables will be measured. First of all, the independent variable will be, as I said already, will be a string that is marked in 7 sections while already attached to the ball, each representing different measurements in centimeters. And these measurements will be measured with a measuring tape and then marked with Sharpie or something that makes a clear mark. And the range and the number of these measurements will be, as I've said already, 7 sections, which is 1 centimeter, 5 centimeters, 10 centimeters, 15 centimeters, 20 centimeters, 25, and 30 centimeters. Now, the dependent variable will be measured with a chronometer. The chronometer will be started and the ball will be put in position. And basically, I wait for a little while. And once the ball reaches 10 seconds, since I'm already here, the ball, once I see that the chronometer reaches 10 seconds, I drop the ball and let it go to stop. And so the materials to be used will be, as discussed, the measuring tape in order to mark the spots of the string. And this is the ball with the marked string and a chronometer. Okay, so after doing the experiment, I was able to gather this data in this table that is presented, which is 1 centimeter took 7.81 seconds to stop. 5 took 88.42, 10 took 9.07, 15, 14.47, 45, 20, 17.07, 25, 22.22, 25, and 30, 26.75. And these are the tables. On the left, we have the table with the raw data, which is just the table and the data that I collected. And the other is the table with the trend line, which is how basically a better representation of this of this data with a corresponding equation. So as we can observe in the data, in the graph, as the length of the string grows, so does the time that the pendulum takes to reach a complete stop. We can also see that the first three don't have that much of a difference, but the difference starts to grow exponentially from there, as we can see here. Okay. Now the table with the trend line. The trend line is used as the trend line used is an exponential trend line. Since we can see that the results get exponentially higher as the length increases. Although it is not perfect, the results are more exponential than linear. And I also included the linear line, not the equation, but the linear line. And you can see it's the one above, the one below, which goes really to other places than the raw data doesn't go. However, the one that is exponential manages to keep most in touch with that. Okay, so now we reach the conclusion. So to answer the research question, the hypothesis I had really was correct, since it accurately guessed that the result will be this way. However, what I did not expect was the sudden increase in the time that is needed to reach the stopping point, the exponential thing that I was talking about. Still, though the hypothesis did not account to this, it did guess the answer, so my hypothesis is correct. However, there were various problems, limitations, and improvements in this, and we can do some improvements here. First of all, the problems that I basically saw is the human errors stemmed from the limitations, and said limitations are the fact that the measurement is not 100% accurate, since I need to start when the chronometer turned to 10. So while my reflexes, even if my reflexes are godly, I may not be able to start exactly and get the exact results. Excuse me for a second. And also, due to my hand being the main anchor point for the string, there may have been some discrepancies in the taking of the measurements. However, there can be some improvements to this. Mainly the improvements that I thought about is that the string should be put in a solid place that can keep it balanced. Since my hand is the one, the anchor point, as already said, maybe my hand was moving here, which ultimately affected and impacted the result. So figuring out a way to keep the string in a point that doesn't move will improve the accuracy of the experiment. Also, another person could be taking the time, and since I was starting at 10 seconds, conversely, recording myself doing the experiment and then inputting the video in a program that helps take measurements, such as Tracker, would improve accuracy. So that's it for my part. This is my bibliography. I just selected something that gave me the basics of a pendulum and how does it work, and the other things that I needed were basically all already in my experiment. And that's it. Thank you very much for your attention.